Morning, everyone. Welcome back to day 2 of the AusCERT conference. We've got our first of the session presentations today. We have Nick Ellsmore with his presentation on the case for backburning your data environment. For those who just joined us today, maybe just a reminder that Chrome seems to be the more preferred browser. So if you are having any issues, it's recommended to use Chrome. And if you do have issues with screen freezing and such, to just kind of refresh or reload the page, and that seems to be the good solution for fixing things. So yeah, you're all more than welcome to ask questions throughout. Nick will do his best to try and field those questions throughout, else deal with them at the end. So without further ado, I'm going to pass it on to Nick. Again, his presentation, the case for backburning your data environment. Thanks, Nick.
Fantastic. Thanks, Aaron. This is, of course, my first attempt at one of these remote presentations, but I think after the last few months, we're all pretty familiar now with speaking into a screen and a camera. So although I can't see anyone, please do engage through the Q&A, particularly, and hopefully this presentation is something that's of value to you. I'll just share this with you. There we go. All right. So for those who don't know me, my name's Nick Ellsmore. I am currently the Director of Consulting and Professional Services at Trustwave. Prior to that, I started a company called Hivent, which was acquired by Trustwave at the end of 2018, being a cybersecurity consulting and advisory firm. And going back further, was the founder of a company called SIFT, which became StratSec. And that was acquired by BAE Systems in 2010. So I've been in the cybersecurity industry now for about 20 years. I have been, I think my first presentation at AusCERT was in 2005, and was on actually on culture of security and the risk of security fatigue. The fact that if we kept running awareness campaigns telling people that the world was going to end, that people would eventually tune out. So it's been a long and interesting journey. So this presentation is, as said, on backburning your data environment. This is a concept I've been working on for a while now, and I've alternated between using the metaphor around backburning and more recently on, I think, Marie Kondo's approach to cleaning, the idea that you should throw out data if it doesn't spark joy. But I think the current one around backburning probably was particularly relevant at the end of last year when I started writing it. Is less relevant now. Now I probably need to find a pandemic metaphor to really tie it to current times. So what I'm going to talk about today is really, I think, what I sort of consider the wonder drug of cybersecurity projects, which is a project that is very low cost. It actually saves you money directly, and so you're very rarely going to have any real resistance to people funding the project, and it significantly improves your risk posture. And if someone came to you and said, we've got the cybersecurity project, it's going to cost next to nothing, it's going to make you money, and it's going to reduce your risk, generally speaking, that's the sort of cybersecurity project that we're all going to sign up for, because it's pretty much the antithesis of every other cybersecurity project that we seem to be investing in. Now, the backburning metaphor. This, in many ways, is what most organizations' sort of data stores look like, and this is not good if you're looking to try to avoid a bushfire, or rather, if you're trying to manage the impact of a bushfire. And part of this is really just highlighting the fact that for organizations at the moment, we've focused so much on data retention and on this sort of concept around big data and the belief that data may somehow magically become valuable over time, that we've built up really, really large amounts of data without necessarily considering the risk that introduces, or the cost associated with that risk. And so metaphorically, this is what many organizations' data stores look like. Technically, this isn't really just leaf litter. I actually think that this is a really, really extreme brush turkey's nest. But either way, if a bushfire comes through, bad things are going to happen. One of the sayings that you all would have heard at one point or another is this concept that sometimes you have to fight fire with fire. Of course, that is effectively backburning. That's that concept. Interestingly, as I started putting this together, I came to find that my understanding of backburning was significantly less accurate than I thought it was. And technically, a lot of what I'm going to be talking about isn't really backburning. It's actually a hazard reduction burn. The concept of backburning is actually that when you have a fire coming towards you, you actually start a fire to basically burn back in the other direction so that you can stop it in its tracks. From a data security perspective, metaphor kind of breaks down if you use that pure definition, because it's like saying that you've already had a security incident, but you're quickly going to jump in and start deleting all of your data to stop it from being taken. While there may be some merit in that, I'm not sort of suggesting that that's going to be the best approach. The hazard reduction concept or control burning is much more relevant. And the control burning or hazard reduction concept is basically if you have huge amounts of leaf litter and other material that would, in the event of a fire, cause real problems, try to get rid of it in the colder months before a fire starts so that you can stop an actual bushfire being much, much worse. This is really, I think, what I'm trying to harness from the perspective of data security, which is, as organizations, we've built up and allowed to occur this, this spread of data, this sprawl of data that we need to start getting under control, and we need to actually start reducing that fuel, because ultimately a lot of that is turning into data breaches and is actually costing us a lot when those breaches are happening. But I did need to have this definition in there because in case anyone was actually in the Rural Fire Service or something like that and objected significantly to my misuse of the backburning concept. And this is backburning just because you can never have too many photos of firefighters. So the simple parallel, look, we can't stop bushfires, but we can reduce the impact of bushfires, and certainly that's what a lot of backburning is about, or hazard reduction burning is about. Likewise, I think we are all coming to terms and are accepting the fact that there are going to be data breaches. It's not going to be possible to fully prevent them from happening, but what we can do is reduce the impact. We can also reduce the likelihood in some cases, but we can definitely reduce the impact. And so in the same way that data is effectively the fuel to a data breach, if there's less fuel, then there's less likelihood that the breach is going to be catastrophic. Now, a lot of you, I'm sure, will come from regulated environments where, for a whole variety of reasons, there is a real concern about deleting data. And there's a real risk about deleting data that you're obligated to keep and finding out later on that some of the data that was deleted is something that is then subject to either court action or regulatory action or something similar. I understand that pain. The main sort of premise of this presentation is simply that there is a cost associated with keeping the information, not just the cost of storage and the operational IT cost, but the cost associated with, from a formal risk perspective, what you would call the annual loss expectancy associated with retaining that data. So my argument is that every record that you retain, every piece of data that you retain has an annual loss expectancy of some kind. And the more data you have, then obviously the higher that annual loss expectancy becomes. And while it's really hard to calculate it, it's almost certain that if we could calculate it accurately, it would actually change a lot of the decisions that we make around which data is stored, how long it's stored for, and so on. One of the other statements that was made elsewhere was, the data that you don't have doesn't have to be checked for compliance against GDPR, doesn't have to be released in a data access request, and it can't be subject to a data breach, which is a really, really simple message, but I think in many ways is also a really effective way of looking at this. So what's the specific data that we're talking about? When I start talking to clients about this sort of leaf litter concept, the data that has sort of dropped off and aggregated on the floor of your organization, it tends to break down to 4 groups, and these are them. The first is old backups, and they may be, old backups that are sort of physically stored on tape or on disk somewhere, or it may just be, backed up systems that have been, sort of archived off and left alone. There's a lot of databases for systems that are no longer in use. Often systems are decommissioned, but the actual databases or the actual sort of content of those systems aren't actually removed. One of the biggest in almost every organization, though, is this third one, which is exports and extracts of data sets that were once used for analysis but are no longer being used. And the reality is the vast majority of this stuff is Excel files and CSV files. And so these are files that have basically been extracted or exported from a live system, have been used for some kind of analysis. They've probably been emailed around, they've been stored on file shares, and over time they've just been forgotten. And every organization that we work with has a vast amount of sensitive data sitting in these exports and extracts that for various reasons have been left and forgotten. And then the fourth one really is I think a more recent occurrence, which is as the cost of storage has started going down pretty drastically, and the ability to scale up storage elastically has increased. You haven't had this sort of the same driver of, we're going to need to buy a new SAN if we're going to keep storing data. It's now just a case of, the storage is just going to keep expanding based on the data that we have. And so there's really a much lower disincentive against storing additional information. And so we've started just retaining lots and lots and lots of additional data just in case. Now, in many ways, the interesting part about this is if you look at these 4, 1, 2, and 3 are often not conscious decisions. So the old backups, the databases, the exports, it's rarely the case that someone has specifically said, let's make sure that we keep that data. It's more a case that the data has been forgotten. Whereas with the 4th case, that's generally a conscious decision. So that's actually a case of someone saying, yes, we definitely want to keep that, again, just in case. And the reason that's important is they're different responses that are needed based on the fact that either you've intentionally decided to keep it or you've just forgotten that it's there. And so the fundamental challenge is often it's a different person that is having to make the decision about retaining or deleting data as opposed to the person who created it in the first place. And I'll explain some of that challenge as we go through. Now, we absolutely aren't the only ones who are seeing this. Jake Williams, malware, Jake from Rendition Sec, some of you may know or have heard of. This literally was just 5 days ago, posted on Twitter that every year they work on cases where they're, as they explain to the victims what the attacker stole, the victim argues about the findings, not because they doubt the methods, but because they're sure the data that we're referencing no longer exists in their networks. And that is exactly what we're talking about here. And we see the same thing in our incident response work as well. This scenario where the data that is actually being compromised is data that from the sort of organization's perspective, they weren't aware that it existed, or they weren't aware that it existed anymore. In one particular case that we saw a couple of years ago, we actually had a case where an e-commerce company had a database that had been stolen, or the contents of that database had been taken. And it was a particularly bizarre situation in that the information they were fed by the attacker to try and get the ransom, try and get a ransom paid. had actually been modified from the original data that was stolen. And so a lot of effort had to go into trying to figure out where this data set came from, because part of the data set looked real and matched up with current clients. Part of the data set looked real but didn't match up to current clients. And then there was also a set of credit card data in there that didn't really make any sense, because the organization had stopped accepting or stopped storing credit card data many, many years ago. And what it turned out had actually happened is the attackers had actually tried to increase the value of the compromised data set by actually adding in a fictitious set of credit card numbers, credit card data, so that when they sent it to the organization and tried to extort them, they could purport to have a more valuable data set so that they could try and extort more money, which was, particularly creative. As it turned out, the organization spoke to the bank about it, tried to sort of cross-reference some data points, found out that the credit card numbers were fake, but ultimately then realized that the data set itself was real and came from a legacy system that they were pretty sure had been decommissioned years ago. And as Jake says, if you don't have it, it can't be stolen, which is a pretty compelling message. So the question at the heart of this concept is whether or not the cost associated with the risk of keeping the data is greater than the cost associated with the risk of deleting the data. So effectively, is the risk higher to have this legacy data than it is to delete it and run the risk of falling foul of some retention requirements? It's a difficult calculation, but ultimately, if you accept that there is a cost on both sides of this transaction, then it does start leading us down a path of trying to say, okay, so we really need to start evaluating it much more accurately and much more meaningfully than we have in the past. Now, the next section, the next few slides I'll run through are actually some example breaches. And I think it's important to contextualize this by saying that there's no blame, attribution, guilt, or anything else implied in this. As the 16th century reformer John Bradford says, there but for the grace of God go I. I think all of us in this industry recognize that data breaches can happen to everyone. And at the same time, we need to be able to learn from them. And so the intent here is to basically look at these and see them as a demonstration of the point that I'm trying to make. The first, Nova Entertainment in 2019 had a data breach. The key point here is that the data set contained details collected between 2009 and 2011. So this is a decade-old information. Some of it may be dummy data, some of it may not be legitimate, a lot of it's not going to be active, there's a lot of expired data, but again, it still goes down as a data breach affecting 250,000 people. ANU had a security breach in 2018. Data was up to 19 years old. It came about through some legacy infrastructure and a legacy mail server. But again, some very, very old data was in there. Adult Friend Finder is another one. They had a data breach of 412 million records. And obviously, given the nature of that site, if you deleted your account, you really, really wanted it to be deleted. It turned out that the hack included some 15 million accounts that had been deleted, but they weren't purged from the database. So they were still there. So even though the accounts had been deleted, that didn't mean that they couldn't be subject to a data breach. And so there's sort of 2 decades worth of data and all sorts of accounts that really shouldn't have been there at the time. Another peculiar one, Symantec in 2019. This is a peculiar one because it really, reading through the information available, seems like there's nothing to see here. It's just test data, maybe some details of clients who had a demo, but given that it's a security company, it's obviously a story when there's a potential data breach, regardless of what the data is. But the key point here again is, this wasn't a live system. It wasn't a key system that was being sort of protected actively. It was, a demo lab. It had some pretty low value data, but it was still something that ended up having an impact and ended up being reported. Another one, Caltex through Accenture. Accenture had some cloud-based storage servers compromised, and Caltex ended up being caught up because they had provided some sets of dummy data across a couple of years before to actually test out the platform. So again, it's not live data, it's a test platform, a dummy platform, and yet the information still ends up being subject to the same type of breach. San Francisco employees retirement system had a test environment. Again, database had about 74,000 members in it, included some pretty sensitive information in there, and the data itself again went back quite a while. So the most recent data was from 2018, but it was an old database and there was a significant amount of legacy data in there. And then I think one of the last ones, Blackboard in the UK Labour Party, Blackboard, which is a service provider, had their system compromised sometime earlier this year. And again, another historic backup file was compromised and ended up with a significant amount of data from the UK Labour Party being stolen. The communication that went out around this is, from my perspective, particularly amusing in that it tells the affected users that the ransom was paid and that the data has been destroyed, and so there's not really an issue anymore. The fact that we're actually relying on the assurances of the people who just stole our data and extorted us to tell us that they've deleted the data, I think is not necessarily a great philosophy. In fact, the last one, so Instagram and Twitter, of course, have both also had sort of security issues raised where they've had this situation where they're retaining data after that data has been deleted. And so all of these really are just referenced to highlight the fact that this sort of scenario that I'm talking about non-production or about unneeded or about backup data, legacy data, old data, the leaf litter in your organization being subject to a breach and causing a problem is very real. And this is just a handful of particular scenarios that we identified pretty quickly. If you go through things like the Privacy Rights Clearinghouse list of data breaches and you start digging into them, a pretty significant proportion of breaches are about non-core systems or about non-production systems. They're about data sets that probably didn't need to be there a lot of the time. And then closer to home, of course, earlier this year, Scott Morrison gave his press conference about the copy-paste compromises. And one of the lines in there was this: the attacker has shown an aptitude for identifying development, test, and orphan services that are not well known or maintained by victim organizations. Now, technically, this isn't about the data. This is about the systems, the compromise vector, but it's a similar issue. Basically, as an IT industry and more broadly as a society, we focus so much on the next thing that we haven't really come to terms with what's involved in effectively decommissioning the last thing and removing the data that goes along with it. And the reality is that if you think it's hard to get a budget for securing your new systems, trying to get a budget for securing systems that aren't used anymore is genuinely nearly impossible. So as Notorious B.I.G. said, "Mo money, mo problems." I would argue that it's also the case that mo data, mo problems. Most organizations will have a clear desk policy, but not a clear file system policy. So we end up with this sprawl of files and this amount of data that is subject to a potential breach. We went through a phase where big data was becoming very popular, and people would say data is the new oil. Well, I think we're starting to hear now this concept that data is actually the new uranium. It has value, but after it's used, it's a nightmare to store it securely, and it's toxic. And I think that's a pretty healthy way to look at it. Another way to look at it is this, which is the value versus the cost of the risk of storing the data that I spoke about earlier. And the argument that I'd make is data loses its value over time to your business but the cost associated with that risk is static. Or the other way to look at that is the value to an attacker is pretty static over time, whereas the value to you goes down pretty quickly. And a really simple example is if you have a record of my last 3 places of residence, that doesn't really help your business a lot. You need my current place of residence so that you can send me bills and you can send debt collectors to find me if I don't pay them. But the historic records don't necessarily add value to the organization. Whereas from an attacker's perspective, that information is quite useful for any attempt to stealing an identity. Because often things like, what are your past addresses, other sort of historic information can actually be used for verifying identity. And so effectively you've got no upside, but you have a downside risk. And so you really need to get rid of that data. At some point, the value of the data to your organization will be less than the value of the data to an attacker. And at that point, you're really in a troublesome place if you're storing that data for a long time. A guy called John Callis, who's a senior technology fellow at the ACLU, the American Civil Liberties Union, actually wrote about this as well. And the way he described it was this: it's very articulate. He says the cost of keeping data are higher than you think and the benefits are lower. There's a chance it will be useful, but there's a chance it will be harmful, like being lost in a breach or subpoenaed in a lawsuit, which is another interesting angle. But the chance it will be useful goes down over time, but the harm value stays the same. If you lose the address somebody lived at 5 years ago, the EU doesn't care that it was inaccurate data that you didn't want and wasn't helping you. Losing it is still losing it. At some point, those lines cross and you should toss the data before they cross. And it's a really, really important point, again, just to have this understanding that there is a value to the attacker or a cost of keeping it, as well as the cost of the value that it creates to the business. Of course, in theory, that's all pretty sound, but there's a reason there are no numbers on this diagram. And that is, there's really no particular science to doing these calculations. And of course, not all data sets are created equal. The other challenge that we have here is the average job tenure in Australia is 3 years and 4 months. Whereas the average data retention obligation is, as it says on the slide, lol, good luck, have fun. It's complicated. The data retention obligation ranges from 7 years for company records to 7 years for fair work, 5 or 7 years under the ATO, 2 years for telco data, no longer than necessary under GDPR, 6 years for HIPAA, indefinitely for certain financial transactions, 5 years for credit reporting, 2 years under the National Credit Code, the lifetime of the security under PPSR, and 3 months for lotteries data. And then the start of that varies from the creation of a record to the end of a transaction, to the end of a financial year in which a transaction happened, and so on. And so the point being that there really is no average data retention obligation, and identifying what those obligations are is actually really, really hard. And so you've got this situation where you've got staff who are on average turning over every 3 and a bit years, and data retention obligations that often run for 5, 6, or 7 years, which again means that the person who is having to decide to delete data wasn't there at the time the data or the system was created, and so they don't actually understand the context around it. Which really necessitates that whenever a new system is built, whenever a new data set is created, whoever is building it or designing it at the time really has to build in with crystal clarity when data can be and should be deleted, because they're the person who are actually in the best position to have that information. Now, when we're looking at the data being stolen, there are a number of different types that get stolen, and I'll skip through this because this is reasonably straightforward. I'm sure everyone here has seen some of this data before, so there's a lot of information about the value of records on the dark web. Now, my recommendation is always to take some of this data with a grain of salt, because the reality is this isn't a hugely transparent market. And although you can see what people are asking for stolen data, you can't necessarily, verify that that's actually the amount that people are paying. Things like patient records are really going to vary in value based on who the person is. Even things like social media accounts, a hacked Twitter account. The hacked Twitter account of Elon Musk is probably worth more than $49. The hacked Twitter account of your little sister is probably not worth $49. So these numbers really, should be taken with a grain of salt. But the key point is that there is a value. Now, whether that value is $1 or $15 or $1,000 obviously has an impact. But if we accept as a starting point that there's a value, then it leads into some really interesting questions. And the main one is this, which is, if you have a certain number of records, files, data points within an organization, then you, in theory, can sum that all up and come up with the amount of value that you're protecting. And if the value of those records is greater than the cost of compromising those records, then bad things are likely to happen. And so what that breaks down to is, it's the simple, if you have $1 million in cash and the cost of stealing that cash is $1,000, then you're probably going to have a bad time. And in many ways, looking at data protection in the same way and figuring out the value of those records to an attacker is actually an interesting way of considering how you can then balance out that cost of compromise. Now, one of the challenges, or one of the interesting pieces here, is how do you calculate that cost of compromise? So one of our clients has a really, really good approach to this, which is they actually use a bug bounty program. And they use basically the cost of we'll call it a sort of severity 1 or a high impact compromise as the indicator of what the cost of compromise is. And what you actually want is the cost of that to go up over time. And so even though that's a cost that you're paying, what you're effectively doing is trying to manage that cost so that you get a consistent number of compromises. So for example, you want to say, our aim is to have one high-end compromise vector identified every year or every 6 months. And so if you start out and you say, we'll pay $1,000 for someone to give us that vector, and you get 10 of them, then it tells you you've got a lot of problems. Once those problems are fixed and you don't get any more notifications at $1,000, it's effectively saying that it's not worth someone's time to identify that compromise, because it's going to take longer than that. It's going to be more complicated. So you increase it to $10,000. Now at $10,000, a whole group of people are willing to spend more time on identifying those compromises than they were before. And so they're now going to come back in and conduct the assessments. And so maybe you start getting them again. And then after a while, all of those ones have gone and they're not there anymore. So now you make it $50,000. And so what you can actually do is use that value of how much it costs you to get a high-end, tier 1 compromise of a system or your organization through a bug bounty program as a mechanism to actually demonstrate what the cost of compromise of your organization is. So then you can basically look at what that looks like versus the value of the records that you're holding, and you can actually start to do these calculations, which means you can actually then start to identify whether you have a problem. So it's, again, this concept that basically every day you're pretty much in an auction for your data. So when we say that it's unrealistic to stop a nation state from getting in, what we're effectively saying is they have abundant resources and you don't. And so conceptually, if we accept the fact that there is a level of investment that, if made, will defeat your controls, then the question we ultimately need to ask is that level of investment at a level that's high enough that it stops a breach? And there are two ways that we can address that. The first is that we can raise the cost of a successful breach, and the second is that we can reduce the value of a successful breach. Now, as an industry, we've spent most of our time on the left-hand side of this. This is putting in place controls, it's introducing new controls, it's tightening things, it's trying to make it more expensive for someone to compromise the organization. We haven't spent nearly as much time on the right-hand side, which is reducing the value of a successful breach. Now, there are some cases where we have done that, and it's been wildly successful. And PCI DSS is really the playbook for this. which is the whole model started being to increase the costs around compliance, to incentivize people to use things like tokenization, to stop storing credit card data, so that it reduces the value of a breach against that organization. If you don't hold the credit card data, obviously you then can't lose it. And so as an industry, we've focused a lot on raising the cost, but we haven't focused nearly as much on reducing the value. And so really my argument is that this utopian cybersecurity project really does exist. And it is as simple as deleting vast amounts of data from our organizations. It costs very little. It will save you significant amount of money, even just from a storage perspective, particularly if you also get to decommission some systems, and it does improve your security posture. So in terms of what we're really recommending, there are sort of three main groups here. The first is establishing this concept of a sensitive data environment. So in the same way, again, taking the PCI DSS playbook, they have a cardholder data environment. The sensitive data environment is a similar thing. It's about trying to keep all of the sensitive data in the same place. It's important to build out a really clear data deletion policy and capture that at the creation of systems and data because of that issue around staff retention over time. But mostly the main thing is really to make this someone's job. For a while, we had this concept of a wiki gardener or a data gardener whose job was basically to tidy up wikis and delete data and improve things. It's really worthwhile to have a role like that. If you're running threat hunts at the moment, consider running data hunts. So try to find sensitive data in places that it shouldn't be. There are obviously all the tools that have been built for PCI DSS that can do this really, really effectively. Or at least allocate this to someone as a responsibility in the same way that you do with fire wardens and work health and safety. So have someone who is actually responsible for trying to minimize the amount of data sprawl and sensitive data being stored where it shouldn't, and who's actively trying to solve that problem. And then lastly, build it into a security awareness program. So have this concept of an amnesty to hand back rogue data, reward people for basically deleting files, cleaning their room, getting rid of sensitive information. And so if we actually start focusing on how we can help organizations to clean up a lot of this information, reduce the leaf litter, do some back burning, I think we'll actually be in a much better position, and we'll end up with a situation where the only data breaches that we see are data breaches of our core systems that in theory should already be the area where we're investing the most from a security perspective, which again is then raising that cost of a breach for the attacker. So hopefully that's been a helpful sort of view on the issue and the problem. I'm happy to take any questions now.
I think we might not have any time. It doesn't appear there's any questions. We might be just running a little bit short of time, Nick. So we might, thank you very much, Nick, for your awesome presentation. We might just have a little bit of a pause between the next presentation and which will be Kushal Shah with Software Zero-Day Discovery. We'll be back shortly, everyone. Thank you.
Lovely. Thanks, guys. Sorry I ran a bit long.
No, Nick, you're perfect. Thank you very much, Nick.
Thanks.